In this video, I'm going to show you how you can use LTSPICE in engineering and enrich your knowledge. I, Dr. Anil Kumar Bhardwaj, feels privileged to share my experiences about LTSPICE in this video. Also, I'm going to add series of videos on various subjects so that you can get better exploration to this particular software. So let's start working on this software. So what is SPICE? We are actually using this particular term from several days. SPICE. So SPICE is basically a simulation program with integrated circuits emphasis. When there is no COVID, we are using softwares in the lab, Multisim, Cadence, Mentor Graphics, or Synopsys, HSpice. So all of them having this particular software in the backend. Although we are using these softwares in graphical user interface, we don't know what is actually in the backend. So the software which we are actually using was originally developed by Electrical Engineering Department, Berkeley. So it was done in the 1970s. So the software used mathematical models to describe circuit elements. So some of them are available in LTSPICE, others we can download and we can include them. So I will show you in my lecture series how you can include any model which is compatible to your LTSPICE and view the results related to that. So when we are using this particular software, the software is being used to get the analysis. So what are the various analysis which we can do using this software? So this is having a very simple drag and drop interface. So very simple commands for analysis. So waveform can be viewed in easy manner and many more terms to explore. So this software is a blessing for all the engineers in hour of emergency. Because of COVID, we are not able to visit the labs and students are getting deprived of precious knowledge. Their fundamentals might be corrupted. So to get that thing right, we can use this software. So students are not able to perform practicals. It is of great utility as every student can be part of technical community and learn this simpler software to enrich their knowledge. So my teacher friends can make teaching more interesting using this software. And I hope you will stay in touch and share your views after using this software. So benefits of LTSPICE. It can be used for simulation in following subjects at basic level, basic electronics and basic electrical. All the active elements are available. All the electric components are available. So you can simulate them and view the waveforms and you can realize what is the impact of changing any parameter. So that we will be discussed when I will share videos with you in the coming days. Then you can use the software in simulation of your linear integrated circuits. We call that LICA or operational amplifier based simulations. Electronics amplifiers, analog electronics, all of these can be simulated on this. VLSI, we can use the software for VLSI. All models up to several nodes can be successfully simulated and their waveforms can be viewed. You can do measurements related to your propagation delay and power dissipation. We can also go for these sort of analysis, AC analysis, DC analysis, transient analysis, FFT and noise analysis using this particular LTSPICE. So these are the analysis we can do. Other are also possible. We will be discussing them in the videos. Right them, I am keeping these things brief. Good thing about the software is it is freely available. Now question arises, how to get LTSPICE software and documentation. So you will go to this particular website, left click on download LTSPICE and you can get this. Follow the instructions to install. So LTSPICE is a standalone application that runs on your computer. No other server or licensing is being required. At this link, you can also download links, demo circuits, LTSPICE documentation, SPICE models, articles, and videos. So this is the link from where you can get all the information related to LTSPICE. Now, what LTSPICE? It is a freeware circuit simulator. You can use it in Windows as well as iOS operating system. Mac users can install from this particular link. Netlist syntax is powerful but hard to visualize. So LTSPICE has a schematic capture and is much more easier than traditional text-based SPICE. The user can enter a circuit to simulated by a graphical user interface. It has a virtual scope and you can make board plots, perform FFTs, and I also mentioned so many other analyses are there. You will come to know when you start working on this particular software. It's worth learning about LTSPICE. It is fast, expandable, powerful, and free. Most widely used non-commercial CAD electronics software. How to start with LTSPICE? That's important. So you can run demos which are available in the file in the software, designed and reviewed by factory apps groups. And you can go to this particular link, and from there you can download. So some already performed zig files are there, so you can use that and simulate that. It provides a good starting point but is not production ready. You can use out part models that are not complete designs. Components are typically ideal components and will need to be modified based on your operating conditions. So these are the things you can do using LTSPICE. So now let's start with LTSPICE. So here you can see this is your first window. When you download it, install it, you will get a window like this. Here you will find out so many buttons, palettes are there. So one by one, I will be giving you a brief idea. Then I will be giving you the live example for LTSPICE. So the first thing is either you can open your link with this particular click or Control plus N. If you want to enable grid, then Control plus G. Then other commands are also there. You can save it. Here by default it is being saved as draft1.asc. Otherwise it can be saved in any other location with any other name. So these are the components. When you place the components from this particular link, you will have all the components available with you which are existing in that particular thing. So they can be connected using wires. So here you can see wire is being there, then ground is there, then net name is being given using this, then resistance, capacitance, inductance, your diode, and other components. So all the components are available there. If you want to move one component at a time, you can use this. If you want all of them to drag, then using this. If you want to zoom in, then minus, zoom out, plus. And if you want to fix somehow, when you're working on this, you will be out of focus. So this particular signal cross is there, it will get your components back on focus. So to add a component, click on the corresponding icon and you can add it. Component buttons are there. You will find out voltage and current sources, transistors, op amps, gates, user defined stuff. So you can delete using F5, move using F7, and drag using F8. So keep the wires connected. So if you want to rotate, Control R is the thing. Otherwise you can rotate it from here also. And if you want to mirror the component, Control E is the command which will help you to mirror. Here you can see mirror is there. So this is your toolbar summary. Right from this, here you can see this is for simulate, this is for zoom in, this is for pan, zoom out, auto scale. If you move out of focus, then if you want to delete something, if you want to copy something, if you paste, find. So all the commands are there. This is for .op is for SPICE directive. If you want to place some comment, that is being done with this. then mirror, rotate, redo, and undo. So these are the commands which are being used and readily given on this. If somehow some of them are missed, you can change from view and add that to your toolbar. Now prefix values. You are using so many components, so it's better to remember this. So tera is for 10 raised to 12, so you put T. No need to write tera ohms and giga ohms. That is being known. When you place in the value, you are supposed to write only the value G. Mega, suppose mega ohm resistance is there, so you are supposed to write MEG. Ohms is already known because you are changing the value of resistance. Kilo K, milli micro U, nano N, pico P, femto F, and no need to enter units. It is assumed that 1 M is equal to 1 millivolt. If entered for voltage, 1 milliseconds is entered for time, and so on. So if it is an inductor, 1 M means 1 millihenry. So no need to enter units. Now let's move ahead. So how you can edit the component? Suppose you are having a resistance, so you will right click on this. So then you can fill the value and you can enter the new value. Similarly, for inductor, you can fill the value like this. Then for capacitor, you can fill the value like this. So quite easy, just right click on the capacitor, this particular component, and a menu will appear, and there you can fill the value. So new value can be done in this particular way. Now component database. So there are so many components that are readily available. So from that database, you can actually select which database you want to select, because in resistances you will have different type of resistances with different tolerances with different power ratings. So you can select that. Similarly, when you use this inductor, they are having different values, different part number, so that can be placed here. Same is the case for your capacitances. So database is available in LTSPICE, so there you can select and use. If that database is not available, what you can do, you can download it from the website and place it and use it. Now suppose you want to make RC circuit, so you place RC, rotate it and place it, connection using wires, then right click and on the source, and you can place the value of voltage source which you are using. Suppose you want to use other source other than DC, then advanced. So this window will appear, and then you can select any of the type of the sources, because a source can be pulse source, it can be sine source, it can be exponential source, it can be PWL source. So there everything is being given. You can place the values and you can go ahead. So that's about your simple placing the component and changing the values. So resistance and capacitance don't have much thing to change. The only thing which can change is voltage source. So you can use this pulse source, you place it, then when you press simulation button on the toolbar, this window will appear. There you will have multiple options for analysis. It can be transient, it can be AC analysis, it can be DC sweep, it can be noise. So I have selected transient analysis. So there you can place the value that at what time you want to stop the analysis, at what time you want to start the analysis, what is the time duration. So you place it, okay. So that will be your analysis. And suppose you want to DC analysis, then this will be done. This is the source for which you want start value of DC, stop value of DC, and then increment. So increment can be selected on the basis of your previous knowledge. If it is too big, you can miss the major events. If it is too small, it will be a lengthy procedure. So the choice is being made by you on your previous or what we can say your experience. So if you have any problem regarding syntax, you can simply click on help, and some commands can be added using .op in the given list. So suppose you want to do this, so you go for simulation and you will get this kind of curve. So when you are in the curve, then you will click on the node. So if node is like this, cursor is like this, you will get voltage. If it is cursor is having this thing, then it is will be current probe. So you will be getting two different things. If you are getting this kind of cursor, that means the value you are getting in the graph is your voltage. If you're getting probe cursor like this, then you're getting going to get the current for the same circuit. So it's quite simple, and I hope you will enjoy this by doing this simple work. So that's all for the day, and I hope you enjoyed this video. And please like, share, and support the channel so that I can put wonderful content on this. So thank you very much. See you in the next video.